All right, so I'm just in the 1.3 playlist. So as always, just click through here. All right, I just want to go through a few things with you. The first is the midpoint formula. So this is where whatever notebook you have, whatever you have with you, I want you to write down um, this formula in there, okay? All right, and the formula is right over here, okay? So it is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So all you're doing is you're adding your x's up, adding your y's up. So if we're using the midpoint formula, okay? And again, the midpoint, so we're finding the point, the middle point. We have on Desmos here, we have these two little sliders and everything like that. So let's just find the midpoint of these two, P of this segment PQ. So if we look at this, we have P is at -4, 3. And remember, when we write coordinates, it's always x first, then y. So all we're going to do to find the midpoint is take our x values and add them up together. So our x value in P is -4, so -4 plus, and then we have for Q, it's going to be 2. All right, so we're going to do -4 plus 2 divided by 2. And then we're going to add up our y values. All right, so our y value for point P is -3. So it's going to be -3 plus 1, which is our y value for Q. All right, and we're going to divide by 2. So again, found -3 right here, 1 right here. All right, so once we do that, -4 plus 2, you can plug it in your calculator. That is going to give you 2, -2, I mean, -2 over 2, and then -3 plus 1 would also be -2 over 2. Now, please don't leave your answer like this. We have to simplify, okay? We have to simplify. So when we do, and you can just do this in your calculator as well, -2 divided by 2 and -2 divided by 2, it's the same calculation. We're going to end up with a midpoint. We're just going to switch colors here. I'm coming up here because I ran out of space, of -1, -1, okay? So that is the midpoint. -1, -1. It's also down here as well. So we kind of just proved that. So again, this formula, please write that down. And it's really what we're doing is we're finding the average of our x values, average of our y values. Okay, when you find an average, you add up the numbers in a data set divided by how many are there. Well, for a segment, we're always going to have 2 points. All right, so we add up those two coordinates, divide by 2 for their respective x and y coordinates. All right, guys. So I'm going to pause the video and we're going to move on to the next part about. All right, so the next thing is I'm just going to share this document with you since there isn't anything like it. We do it in a different way than the book does it. So it's just called 1.3 Finding the Other Endpoint. The problem up here, that's something that you can look back on and kind of do yourself, all right? I'll put the solution in there. But then if we're going to do this one, it's a little bit trickier, and this is the one I want to start with just because we're going to go through it, and it won't be too bad. This way is a lot simpler than what they're going to show you in the book. So if we're trying to find an endpoint, so what it's saying is that, and all these problems are kind of going to be written the same. It says the coordinate of point A are -5, -3. So A is down here, and then the midpoint, it tells you the midpoint of this line AC is at B. So that's the midpoint. And B is at 2, 3. So we're not finding the midpoint of this segment. B is the midpoint. What happens is the segment keeps going and C is somewhere up here. And we want to find out what the coordinate of C is. All right. We don't know what it is. So to do it, what I'd like you guys to do is set up your problem like I have set up right here. Okay. And I do this because it kind of keeps it in a line. And then as we're going down, this is kind of like our little line segment, I guess, our little line segment that we have. And so here's our segment. B is in the middle, just like you would if you were drawing the line segment. That's what I think about, okay? Now, to do this, all we're going to do is we're going to figure out what is the distance from the x-coordinate in A to the x-coordinate in B. So we're going from here to here. if I'm going from negative 5 to 2, and again, if I'm on my number line, okay, I have negative 5 over here, all right, and I'm going all the way to 2, and I got to pass through 0. So this is the way I think about it. If I'm going from negative 5 to 0, you're going to think, well, I've traveled a distance of 5 units. So if I travel this far, I traveled 5 units. And then if I travel to 2, I've traveled an additional 2 units. So I've traveled 7 units. All right. So we're going to do the same thing to find the x-coordinate for C. We are going to add 7. 2 plus 7 is 9. That's going to be the x-coordinate for C. Now all we have to do is we have to do it on the other side for the y-coordinates for A and B. So if we look at that, we're starting at negative 3 and we're going to 3. So on our number line, we're at negative 3. 0's right here. 3's over here. We're traveling to 0 first, so we're going to add 3, and then we're traveling to a positive 3 again. We're going to add 3 again. So 3 plus 3, that's going to give us a total distance of 6 units. So then we're going to travel another 6 units to get our y-coordinate for C. I'm going to add 6. 3 plus 6 gives us 9. So the endpoint for C is at 9, 9. Okay? All right, guys. And there's an additional example that if we need to go through that, because I know this is just one, we'll do it in class together. Okay? So I'm going to pause the video and we're going to move on to distance. All right, so I'm just going to click on the 1.3 concept distance formula. And so for this, we have the distance formula. It's this longer formula. All right, it's right here. Okay, a lot of steps going on. So this is one you have to make sure you write down everything. And we're not going to plug everything into our calculator right away because we'll probably make a mistake there. Okay, so for this, first of all, please write this down in your notes. All right, guys. And have that with you. And then we are going to do another example together. All right. Another example together. So I'm going to pause the video. All right. So I'm going to click on additional example 4. All right. And so this, it says find the distance of KL, give the answer to the nearest tenth. So that's one thing. For using the distance formula, we're going to take the square root. We're probably not going to get an nice even number. Okay. So it gives us the solution here. And this is where the first thing we need to do is we need to find the coordinates for K and L. All right. So if we look at that, K is at 1, 3. All right. And then L is at 3, negative 2. Okay. All right. So now the distance formula that we have is the square root of, x2 minus x1 squared plus y2 minus y1 squared. This is what we're going to use all the time. For this is where I would just label your points or even just make it as simple as making this like our first coordinate and these are our second coordinates. Okay, if we do that, then we're saying this one's x1, y1, this is x2, y2. And so then we're just going to plug those in to our formula that we have, okay? So what we're going to do here is, and I think it has a solution written out for us, so I'm going to go through that with you because it's a little bit neater. And they have, and this is why I want to go over the distance formula, they have it written a little bit different of a way with XL and XK, YL and YK. You can do that, but we can always just stick to our X2, X1, Y2, Y1. Now, it doesn't matter what you pick for your ones and twos. You could reverse it. It doesn't matter. All that matters is that we stay consistent, okay? So if we said that, we're going to use K as our 1 coordinates, then we have to stay consistent with our X's and our Y's. So for this, to find the distance, we had our coordinates. I'm just going to rewrite them as 1, 3, and also 3, negative 2. So what they're doing is they are taking the L first, all right? They're taking the XL, so that would be like our X2 that we had, all right? And they're plugging it in. So they're taking this 3, they're plugging it in right here, all right? And then they're taking the y, or not the y, the x coordinate for k, and they're plugging it in right there, okay? So that's what they're doing. Now, the next part of it is they are taking the y coordinates. And again, we started off, and this is where you have to stay consistent. We started with our coordinate L, so that's why we're going to start with our -2, and they're putting that -2 right there. And then we're going to subtract the 3, and that's why we put the 3 right there, okay? So after we do that, you guys are going to want to plug this in your calculator all at once. Don't do that, okay? Simplify what's in the parentheses and square it, all right? So what they're doing is, and I'm just going to kind of draw an additional step over here, all right? So to simplify it a little bit more is they're saying 3 minus 1. Well, 3 minus 1, so if we take the square root, 3 minus 1 is going to be 2. So we're saying 2 squared plus, and then -2 minus a -3. That is going to be -5 squared, all right? Now, in your calculators, in your TI 30X whatever, or graphing calculator, anything, when you plug in, if you just plug in -5, all right, squared in your calculator, which we know -5 squared is basically saying -5 times -5. If you do a negative times a negative, it's going to give us a positive. Now, if you do this operation in your calculator and just plug it in just like that, what you're going to get is you're going to get -25. That doesn't make sense. This is distance. We already talked about how distance has to be positive, okay, in our other section. So what you need to do, you don't want to do this method. You want to put parentheses around the -5, then put the squared symbol. That will say, all right, -5, we squared, it's -5 times -5. That will give you 25. So always use parentheses, okay? So now moving on to our next step here. This is something, the 4 plus 25, that's something you can plug into your calculator. All right, you don't need to add the 29, right? You can just plug that straight into your calculator and get your answer of 5.4, and it said round to the nearest tenth, so that's why we just left it with 1 decimal place. All right, guys, so if you have any more questions or anything like that, please ask them while we're in class here or through email, and I can help you out. All right, guys, have a great day.